All right, hello students. Here we are at video 6.6, almost to the end of the unit. Unit title, you know it. The objectives today are I can identify rigid motion and I can find translation images of figures. Remember, the IXL skills you should be focusing on are L1, L2, and L3. All right, let's get right to it. Let's go, flippers. So we're going to start off with a definition that you may have, but I just want to make sure we all have it and we're very clear on it. So a transformation. Transformation is when a figure's mapping results in a change in the position, shape, or size of the figure. Okay? So again, a transformation. These are very important. When we have a figure, so let's make a figure. Here's figure ABC, and we're going to call this figure the pre-image. Okay? So the pre-image is the original figure. And here we have our image. Our image is going to be the alter figure, the figure that has been changed. And we can clearly see that these two figures are not congruent, not because their angles are not the same, but because clearly their side lengths are different. So this is an example of what can happen with maybe a dilation, which is something that we'll actually look at later on. They may be similar, but these figures are not congruent. So the first definition that I want to talk about today, specifically that I want you to write down, is going to be rigid motion. So rigid motion is when we have a transformation that preserves distance and angle measure. So above the example that we use as pre-image and image, this would not be rigid motion because it's clear that these two figures are not congruent. They're not the same. The angles may be the same, but the distance of the side from A to B is not the same here as A prime, B prime. So let's look at this example that we have here, and it says, does the transformation appear to be a rigid motion? Explain. Well, here's our pre-image, and here's our image. It's very clear that these angles are still the same. Corresponding angles are similar, and the side lengths are also the same. So this means this is a rigid motion, so our answer is it's clear again because, yes, the corresponding angles and sides are going to be the same. Now, it's important to write the word isometry. Isometry is a word that means same angle, same size, and congruent. So when we find things that have rigid motion, they are also isometric or they have isometry. Today's focus is going to be on translations. And translations are transformations that map all the points on the figure the same distance in the same direction. Here's a segment AB. And we have a translation for this that says it wants us to translate, that's what the D stands for, 1, -1. So that means we need to go to each point and we need to, along the X, we need to travel 1. And along the Y, we need to travel -1 to our new locations that will give us our image. All right? So clearly we have our pre-image. Here it is. Let's make our image. So I'm at A, and I'm going to travel from A because it says X is 1, so I'm going to go to the right 1. That's adding 1 to A, and then I'm going to go down 1 because that would be, so to the right 1, down 1. I'm going to make a point there. So that's my new A prime. I'm going to go to B. I'm going to do the same thing. It says right 1, so right 1, down 1. It will be a point here for B prime. I'm going to connect those 2 points, and look, I made a translation 1, -1. Okay, so our first example says, does the transformation below appear to be a rigid motion? Here we have a pre-image and an image. It looks like the angles are the same. Clearly, they look like right angles, but we couldn't say that for sure. But it is clear that these side lengths are not the same, so distance has not been preserved. So we're going to put no, because these are not the same. No rigid motion. All right, here we are at number 2. It says, what are the vertices of translation -2, -5? Don't worry about those little brackets. Sometimes people put brackets or parentheses. Doesn't matter. Translation -2, -5. Graph the image of PQR because they've given us the pre-image. So let's graph our P prime, Q prime, R prime. So here let's use blue. So again, I'm going to go to R and I'm going to go to the left 2. So I'm going to go left 2. So here that'd be 1, 2, and I'm going to go down 5. 1, 2, 3, 4, 5. Make a point. And that point will be R prime. And do the same thing for the other 2 points. Here's our last point, P prime. Then I just want to connect them. And there we have it, a translation. So here's our final example, is question number 3. It says, what are the vertices of translation T1, -4? Again, they want us to copy it and graph it. Here you can see I've graphed the points. I'll connect them now. I've actually written the points over here as well so we can actually see what's going to happen to them. So let's go ahead and do what we normally do and go to the right one and down 4 for each point. There are 3 points, and let's connect them. And what's so cool about these figures is, yes, this is actually a rigid motion transformation. And I actually want to write out that this has a rule, and there our rule is, okay? So again, you want to make sure that you can talk about these ideas, that 1, these 2 figures are going to be congruent, and that you can have a rule for it as long as sets of points. You could actually graph these or write the points down here for the image that we have, the pre-image versus the image. All right, on to the question, the secret hot one. All right, so our secret hot question is, what is the rule that describes a translation that maps PQRS to P prime, Q prime, R prime, S prime? Here is the pre, here is the image. How do you get from here to here? Make sure you write a beautiful, lovely rule for me. And remember, your IXL skills to work on are L1, L2, and L3. Get those done. Have a great night.